Hello everyone. Today we are going to speak about Ruptela fuel level sensor configuration and calibration. The first thing that we would like to start with is our device configuration. We need to configure the device, first of all, in order to work correctly with our FLS and to be able to get the fuel level sensor data from fuel level sensor. First thing that you would need to do is to choose the COM port where your device is connected to from your PC, and then to press on connect. Next step is we need to read the current configuration, which is being uploaded to the device at the moment, in order to edit it and send it back after we configure the device. Now, configuration is loaded to the configurator. Next step, we need to go to I/O events. After clicking on I/O events options, we have this window appeared. Now you need to know to which board you are going to use the fuel level sensor. We have two RS-232 interfaces or ports in our device, port A and port B. If you are going to use port A, you need to check this box and to make sure that the selection is set to DFS RS-232, which means Digital Fuel Sensor RS-232. If you are going to use port B, you need to make sure that you are going to select the same option. So you check the box of port B and then you select Digital Fuel Sensor RS-232. After finishing configuring this part, we need to enable the I/O events related to each of these interfaces, which the device going to send this information to the server containing the data of the fuel level sensor. If we are going to use port A, we need to select any disabled slot from this menu. For example, this one. We click Enable, and then we select from the drop-down menu Digital Fuel Sensor A1. This is in case if we are going to use port A. If we are going to use port B, you need to select another disabled slot, and you have to click on Enable, and you select Digital Fuel Sensor B1 I/O parameter. You need to make sure that configuration is set with the current condition shown in front of you. Make sure that the average is set to 20,000 milliseconds. After that, we need to send the configuration back to the device. After the configuration is sent to the device, now the FM device is ready to be connected to the fuel level sensor and to receive the data from it and send it to our server. After finishing the device configuration, now we move to the fuel level sensor configuration. Now we will start to prepare our fuel level sensor. We will configure it and calibrate it in order to read the fuel level data accurately. First thing before we start, you need to make sure that the fuel sensor is powered on and it's connected to your computer. Once it's connected and powered on, you can see the COM port which is available and your fuel level sensor is connected to. For example, on my PC, it's connected to COM 12. After selecting the COM port, now you need to move to the next part and connect the fuel level sensor. After connecting it, you get a warning message asking you if you want to read the current configuration which is uploaded previously in the fuel level sensor, and warning you that the configurator data now will be overwritten. You click on yes, and configuration is received. First of all, before starting configuring and calibrating the fuel level sensor, you will need to prepare the fuel level sensor by cutting the probe to a suitable length. I will leave a link to the fuel level sensor preparation and an installation video in the description. You need to see it first before starting the calibration process. Today, we will do a wet calibration. For that, you will need to bring a tube full of diesel, or in case if you are in the field with a vehicle, you need to make sure that the fuel tank of the vehicle is full so we can use it for the wet calibration. To do the calibration, you need to move to the calibration module from here and you need to make sure that the setup mode is checked. Once we enable the setup mode, now we will be able to start the calibration of the fuel level sensor. You need to record the measured C value for when the tank is full and when the tank is empty. So full tank C value and empty tank C value will be measured accordingly. Now my fuel level sensor is completely dry. It's not touching any fuel. So we will use this current value as an empty tank C value. To do that, you need to press on this button. Now the new value is set to 3 as it's shown in here. Once I start to insert my fuel level sensor in the fuel tube, which is full of diesel, we need to make sure that the fuel sensor is completely merged in the fuel. To do that, you need to put the fuel sensor and watch the values. Now I have inserted it inside of the diesel tube, and as we can see, the values are increasing. We need to wait until it gets stabilized and until it reaches a certain value. When it looks stable for you, you need to register this as a full tank C value. Now it looks stable. We can register this as full tank C value. Afterwards, you need to click on Calibrate. Now you get a warning message asking you, do you really want to change the empty and full tank values in FLS? You press OK, and calibration completed. Afterwards, you need to send all the configuration to the fuel level sensor, and configuration is sent and calibration was done successfully. Now we need to prepare the calibration table. The calibration table is being used for the tracking platform to provide you what values the sensor is sending to the platform and what is the fuel liters in the tank corresponds to this value. To do that, you need to go to the real-time data and you need to keep an eye on the fuel level N values. Fuel level N values is the same value which is going to be sent through IO parameters, digital fuel sensor A1 if you are using port A, or digital fuel sensor B1 if you are using port B. You need to record each N values and what or how many liters in the tank corresponds to this value. For example, if you have a fuel tank which capacity is 100 liters, you can do 10 liters by 10 liters. If it's more, let's say 400 liters, you can do 20 liters or 25 liters by 25 liters. So once you add fuel in the tank, you need to monitor the fuel level N and to record 25 liters corresponds to fuel level N value, and then you need to record it. For example, once I merge my fuel sensor in the fuel, you will monitor that and you will see that the fuel level N is increasing accordingly. Now, my fuel sensor is completely merged in the fuel, and as you can see, fuel level N value is 4095. If I remove it from the fuel, it corresponds correctly. After making this table, fuel level N value, and how many liters corresponds to for each fuel addition, you can provide these values to your platform administration or technical support, so they will insert these values in the platform, and afterwards you will be able to read the fuel data accurately.